that we can eventually put on the personal space for the station network server. So one of the things we were advised to do by the High Performance Computing Center team was to convert from using Apache over to use Nginx. And so we did a mock conversion using a virtual machine on of that today, and we were able to get it running. So I'm thinking potentially either this Friday or the following Friday, we'll then take the PSWS network server down for a few hours during the day and update it to have Nginx. It's a simpler configuration and seems to be a bit more secure. It's just more up to date than Apache. So that's the news from here. Back to net.
Okay. Well, good for the heads up. Next on the list is Dave Witten. Go ahead, Dave.
Oh, I've been keeping myself occupied. I don't know what all I've been doing. Uh, it's cold here, and I'm though I'm sure it's cold in many places. Uh, I've been working on adding a WebSockets interface uh, to the magnetometer agent that can be used for make data collection work different ways on that, and that's part of making um, a, working with Jackson, Conti, and Nathaniel to get a dashboard type tool for that. Been doing a little 3D printing, a little of this, a little of that, and um, trying to stay busy and warm. Um, Otherwise, not much, not much of excitement.
Okay. Next is our dear friend iPad 2.
That's Hi, Dave. Yes, I'm on the iPad,
Go
and I'm in
ahead.
my comfy easy chair. It's cold here. We've got about 20 inches of snow, but it's light and fluffy. But I've still got a lot of it to move before an appointment tomorrow morning.
Oh,
Uh,
well, good.
the
Good.
technical news here is I fixed the balun I blew up as of the result of ice on the 80-meter dipole from a previous storm that actually put a lot of strain on the extra strain on the wire wrapped around the cores and broke down the insulation. So anyway, that's the progress here. The bad news is it looks like the cold and snowy weather has brought the power line noise back on
Oh,
the Whisper Demon. So I gotta hope that'll go away with the cold weather. But
yeah.
back to net.
Well, next on the list, we have Dave H, W6OQ. Go ahead.
Good evening, everyone. Not much on radio this week. Had carpal tunnel surgery this morning. It's going well. That's it.
Well, good luck with that. And next on the list is David McGaw in one HAC. Go ahead.
Hi
Oh,
guys. Been playing with 450 megahertz stuff for our CubeSat telemetry and egg beaters, antennas that is, and preamps and notch filters to get the 452 megahertz out. There's a challenge. Um, and then we got 15 inches of snow, and it's still coming down. So I've been dealing with that all day. And Bob, if you got power line interference, I just got off a call with the New England Spectrum, what do we call ourselves? Spectrum Protection and Use uh, Committee or whatever. and there is an Eastern Mass group that you can call out to search down power line noise. So, we like to be used.
No, thanks, Dave. But I've got some resources here.
I'm sure you do.
So we'll see what comes up. But
Yep, it is a eternal problem. Anyway, I guess that's about it. It's actually a balmy 15 degrees here. It's been down around zero
Oh.
for several days.
Yes.
So back to net.
Okay, Nathaniel, I'm gonna go back and catch you since you were just a little late.
Great. Hi, everyone. I'm here. It is a warm and sunny 9.5 degrees here in Springbrook Township. I've been busy keeping all of the projects running. I'm really trying hard to get back into the MSTID research and trying to move that forward. So I've been working on that project for the past couple of days or so. And before you know it, classes are going to start for me on Thursday. And, just getting going with that again and trying to make sure the HamSCI workshop, goes off without a hitch. So I know abstracts are due in a few days, so please get those in. And other than that, back to net.
Okay. And next on the list is Jay Schwartz, WB8 SBI.
Yeah, good evening, everybody. From the frozen North Country here outside Detroit, where we've had wind chills at night, anywhere from -5 to -15, and they're possibly calling it for even colder tonight. And we're digging out from the snow from yesterday. We're all dug out, but you know, it's winter. What can you do? Um, Nathaniel, did you get my email? I sent you an email today.
I saw it come through, but I didn't have a chance to answer it. I think it was about the hotels.
Yeah,
And the short answer is I'm waiting to hear back. Bob Inderbidson's working on it, and as soon as I know the information about it, it will show up on the website. So
okay,
it's still being coordinated.
okay, that's what I needed to know. Because we're starting to make our travel plans here. We're going to drive down, and from here it's a 2-day drive. Unless you want to knock yourself out and do it all in one day, but it's a 2-day. So anyway, other than that, uh, I'm still trying to fight getting Windows 11, figuring out why it's not installing on my machine. And I've also heard that because of the explosion in data centers that are sucking up a lot of RAM, that RAM has gotten horrifically expensive these days. I haven't priced it. That's just what I've heard. So if anybody has any information about they've tried to buy RAM at all, to just, nothing special, just ordinary RAM to upgrade a laptop or a desktop, if you'd please comment about that, if you've seen any price hikes like that. Other than that, 73 all, stay warm, stay safe, take care. Back to net.
Okay. Next on the list is Jonathan, KC3EY. Go ahead, Jonathan.
Hi, everybody. Um, this past week, actually last week, I figured out the issue with the GPS interface board. It turned out that the GPS module and the 3.3 volt voltage regulator has had a short on the both on their input and output respectively. Other than that, the board is fine. Paul, I could give you an update in the general session. I'm also planning on getting everything I need for finishing the installation of the Whistler catcher preamp and antenna at Nathaniel's house. Hopefully going to do that Friday if the weather permits. And I've also been involved in trying to get the measurements right for the end panels on the VLF interface board for its aluminum uh, aluminum enclosure. I finally have my printer and I could do test fits with paper printouts. That's all I have. Back to the net.
Okay. Next on the list is Michael Howen. Go ahead.
Good evening, everybody. I've mostly been working on some programming. I did have a meeting with Sarah over at Virginia Tech and Anna Montare, formerly from Case Western, a graduate, I guess, of Case Western, and she did some work at WWV as well on some timing possibilities in software. So we're going to keep the conversation going over that. Otherwise, that's about it. Back to Ned.
Okay. Next on the list is Paul, WB6 CXC. Go ahead, Paul.
Yeah, good evening, everyone. Yeah, I just really showed up for the regular beating because I haven't been working on the RX. But actually, I did a tiny bit of work on it today, so maybe you could skip, only give me, you know, 3 strokes of the cat o' nine tails here instead of the full 12. Um, I I promised a couple days ago to work on uh, the time sync, sort of a document describing what we've done and where we would like to go with it. Um, I've just only just begun on that. Last week, I kind of moved to the top of my priority list, stuff that I'm helping with at the local high school STEM center here. A bunch of hams, uh, s- teachers, just amazing, and a bunch of the students are new hams, and they want to do some stuff. They want to do a fox hunt, VHF fox hunt, and they want to actually build the controller for the transmitter. So I said, yeah, sure, I'll help. And so I spent last week figuring out, what the options were for them, something that they could build. You can buy this stuff, but wanted them to be able to build something with through hole components and all that. So this is what I came up with. I'll unplug it here. Ignore the stuff that just this audio interface, coupling transformer, an RC low pass filter, and this, which is you can't see, but it's a Pico 2 microcontroller. Used to cost only $4, but now the price has become an exorbitant $5 each. That part is amazing. It really is. So I'm running uh basically wave files, converted wave files that I record, so we have tones and we have voice identification and the things it's just working great. The only trick was getting the radio. I want to power like this little Baofeng radio transmitter off the same charger or battery pack. It's one of these lithium guys. Have them both plug in, have both my little micro board here and the radio plug into this battery pack. And of course, the USB voltage levels conflict. So I needed to do the isolation. Anyway, so this coming Wednesday, I'm going to be bringing them a bag of parts and some proto boards and, help them solder that stuff together and give them the software so they can learn how to modify it and maybe you learn honest to God C code instead of that newfangled Python. We'll see. So anyway, um, that's about it. Oh yeah, one interesting thing, Dave. You recall those balance that I did, and Tapper now has the
Yes.
files for. I don't know if you got, not been a hot seller here at Turn Island Systems, but JPL got a NASA thing going. They're doing a unmanned, airplane with doing aperture rate, synthetic aperture radar stuff, and they want to use some of those to run some of their signals where they want the balanced signal rather than just running coax back and forth
Right.
on the thing. So that's kind of neat.
There you go.
I'll be thrilled to have something. I had something that I designed go up in the space shuttle once. Not the one of the ones that exploded, fortunately. But it's been a while, so it's kind of makes me uh makes me happy to have something like that go up in a NASA program. And that's about it. And Jonathan, yeah, after everyone's done, I would love to hear about the details on that those short circuits. Okay, back to you guys. Back to Net.
Okay. Next on the list is Phil, K9Q. Go ahead, Phil.
Hey guys, not too much to report since I just came off jury duty for the last 2 weeks and something I'll take a while to get over. I am starting to get back into plowing through pull requests and issues on KNIQ radio, but just getting started that again. So back to you guys.
Okay. And then let's see. Next we have Scott Newell, N5TNL. Go ahead.
Hey everyone. Not much to report this week between work and weather. I didn't do any radio stuff, so back to Net.
Okay, and then we have, I believe Rob. There was another guy in there from Missouri, but I didn't. He seems to have disappeared. But next we have Rob Robinette. Go ahead, Rob.
Hi. I've been mostly working on the Whisper Demon database. I have a system upgrading, and I now have we now have a complete clone of the whispernet.org database. I downloaded all their 160 gigabytes of archive of spots back to 2008. And I cleaned up their database, their spot lines, and then recorded them into a ClickHouse database that's on hardware that I've maintained. So that was time consuming. Not so much for me, but it takes hours and days to transfer that much data and to even to process it. So that's been the major effort. I'm and I'm still working on that. So that's my major focus. Can't think of anything else to talk about at the moment that's immediately relevant to the group. So I'll send it back to you guys.
Okay. So I believe I've called on everybody, so we're open for general discussion.
I have a question for those of you. I have out at KPH, they've lost their dedicated phone circuit between the transmit and receive sites. And so they've asked me to see if there's some internet-based solution that would provide the same, basically, bidirectional phone line. Low latency is important, of course, because what they're using is they're sending tones down this phone line from the receive site to key the transmitters. So they're keying for CW keying. So latency and a clean response is important for them. I don't know if anyone here has experience doing that, but
Why is latency important? Are they doing full break-in?
it's well these are I don't know, these are code jocks. I don't know what they're doing, Phil. They're sitting there pounding away on their keys when I'm when I'm out there working on the
Yeah. Well,
SDRs.
the usual problem is when they went full break-in, and like any SDR is a real problem for CW operators that want that. Because the
Yeah.
latency requirements are so tight.
Yeah, they're not going to be using SDRs for their CW work.
No.
The
They've got these
old,
old Kenwood
yeah.
transceivers that they from the 90s that they use for receivers, but the transmitters is sitting 15 miles away, and I don't know. They have no idea what their latency requirements are, so I don't know. I did a Google Claude search and came up with you can do it with FFmpeg. Just tell it to use a PCM codec for the audio, limit the audio bandwidth to 4 kilohertz, and you've got a stream. It's what is it, 256 kilobits per second, and uh, the latency is largely the transmission time across the network. That's what I believe, what I've read and been told by Claude AI, but I haven't tried it out yet.
Could it be done with a UHF link?
Well, there's no direct that they've explored that, but there's no line of sight, no direct connection, so it'd have to go through a relay. And it's yes, it's doable that way. That would be the classic way to do it, but it sure be great if they could just connect a couple of pies on each end and use their internet connection.
How far apart are they?
They're about 10 air miles, but there's no the wired connections are even the wireless internet connections are longer. But I don't think I suspect I was suggested we do a measurement of the ping time between the two sites.
What were they sending over the phone lines? I mean, was it
Tones,
just audio of some
DTMF.
sort?
It's DTMF tones that are used
Okay.
to key the transmitters. And apparently there's a need for a back channel as well. So there's mostly is a forward channel to key
ETMF.
something like that. Yeah. This is all out of the 90s, This is a historic radio
The
site.
90s isn't that long ago. Come on.
I know, but
Making me feel old.
but the stuff that was there was probably from the 70s. That's what I see when I go out there. Stuff that the
15,
newest stuff is from the 70s or the early 80s. It's
15 miles isn't excessive miles for any VHF or UHF link.
well, according to Richard, who runs the place, that they would have to put in a relay site to get a decent connection between. There's a ridge. There are multiple ridges between them.
Why did they lose their phone line? Was it an actual telephone company provided line?
Yeah, the telephone company apparently just.
Oh yeah, they've never wanted to sell wire copper metallic pairs. I mean, that's been true for a long time.
Yeah. So Richard is, he's an experienced guy. So and very well connected in the community up there. So if it were possible to get the phone line restored, I'm sure he would be doing that. So
Yeah, in Occidental, which is, isn't that different county, Sonoma instead of Marin, but it's still not that far away. I eventually just had to get rid of my wired phone line because just maintenance took so long, and the lines were getting so old and corroded and water damaged and noisy, and there's just no way that um, Pac Bell was going to, or whoever's maintaining the lines, was able to keep on top of it. So it just was not reliable. So, now I'm, down there, I'm on internet phone, and it's great. And, the latency doesn't, I don't know what it is. It's not like, not like sat phone, where you can, hear the latency for sure. But um, just plain old internet phone might be fast enough.
well, he says they're using a VoIP modem right now, but latency is noticeable, intrusive to them.
Well, they might, you know, uh, I honestly don't know what we're using. It's just a box that we got from the fiber people because we got gigabit fiber running out to our
Yeah.
place in Occidental. The whole road got it.
Latency
But
is the Faustian bargain we've all made to use digital communications.
Nah.
yeah, but there's millisecond latency, and then there's
Right,
100 millisecond latency, and
right. Big
Yeah.
difference. Yeah.
Well, I think that the one could adjust, especially don't do any compression. Although maybe compression gives you something because it makes your packets smaller, so you can send them more quickly. And
well, they don't get there any faster. It's just
no, but
less
they're
to send.
smaller. They're smaller. Maybe.
Well,
So,
going
Okay,
forward,
okay,
yeah.
sure.
I know it's
Going forward matters only if the links are slow.
Anyway, I was, I was going to explore just trying to use FFmpeg between a couple of pies and see how well that works. But that's one of my background projects here.
I know this probably won't address the situation, but I do want to point out there are a group of people that have devised internet capable boxes of sending landline telegraph signals across the internet. So that's also probably 90s technology, but maybe 1890s
Landline
technology.
telegraph, like
Yeah,
the old Morse, the old
yeah,
continental
American Morse code, yeah, Continental Morse
the
code.
the
So
one
there's
we don't know is hands.
that's
Yes.
correct. But
Yeah.
like if you go up to, I've seen demonstrations of it at Dayton, and also I know if you go up to into the Antique Wireless Museum in New York, they have a whole telegraph station there, and there are a bunch of people out there who know Continental Morse code, American Morse code, use actual sounders and that old equipment, and they're all linked together by internet links these days. And they have it all worked out, and they seem very happy. So.
Well, that'd be a reason to go to Dayton then, huh?
My mentor some years ago was raised in a railroad station, small railroad station in northwest Indiana. His parents ran the station and he was in the cradle beside the disc. And he grew up as the assistant operator and floor sweeper and things at the station. And he would get on 40 meters and he'd be talking to somebody and says, this guy knows what he always said was Morse code. And they would get on and go back and forth with the telegraph code of the early 1900s. And I've heard him on doing that. And you can copy some of it, but not all of it.
My great grandfather was a telegrapher in Wisconsin, and he was also during World War II. He received a lot of the telegrams that he had to walk up the hill and hand to family
Mm.
about their lost soldier.
I've also seen I've been to their website, the group of people who are into American Morse, and what they do is they connect their sounders and their keys through, I believe it was hardware serial ports. They use the control lines. They use the control lines to interface their sounders and their keys to the computer, and it runs software and it transmits that over the internet. It's actually pretty cool. And one of my projects before VLF was the intention on getting one of those old Bunnell sounders and interfacing it to my computer or terminal server and getting it running with the client software so I could at least listen. But those people do exist, and they're an interesting bunch of people.
I've got a sounder and a key sitting in the basement. All I need is a battery.
some
One
big
of those glass giant batteries they use at central offices.
Well, I think a lantern battery would run it.
Okay, what are they? Salmoniac filled or something? Anyway, hey, Jonathan, can you tell me or tell us about those shorts? Were those, layout trace shorts, or was that soldered, soldering shorts, or what happened there with those shorts?
So it wasn't an issue with like solder bridges or anything else like that. So first I desoldered the module. I had a tip which would allow me to very easily desolder the module. So I desoldered the module. I cleaned off all the solder and everything, and the VCC and ground are shorted. It's like 4 ohms. So there's a short there. So with the desoldered and everything cleaned but there was still a short on the 3.3 volt line. So my next thing was, oh geez, well let me remove the regulator because that was the next thing that was stressed.
Mm-hmm.
So I removed the regulator, and then the short went away. So on the output of the regulator, there was also a short. So it was something I'm almost positive that it was a moisture issue with the module, which caused something to fail and create and make a short. And but yeah, that so everywhere else on the board, everything is good. The 5 volt is good. The board itself is in pretty good shape. It was
Okay,
just
now wait, this is a short on the 3.3 volt bus, right? To ground.
no.
No?
I ended up removing the 3.3 volt regulator,
Yeah.
and I tested. I measured on the output of the regulator.
The pad on the board.
No, the actual individual.
Oh, the chip, the part,
Yeah.
it's the regulator itself. So the
Mm-hmm.
regulator had a shorted output
Yep.
to its ground pin.
Yep.
Okay.
Yep.
Okay.
Yeah.
So bad part, whether and what caused that is open to speculation.
Right.
Okay.
But
Well, that's good. I'm glad you found it. Sorry you had to pull the GPS chip module off the board, but
well, that was a goner anyway. That was also already shorted. So,
uh
but uh,
I'm have you measured the I mean, because what have you done with that module since you removed it? Because you still had the short after you removed it. So maybe the
well,
module's good unless you've done some other measurements on it.
oh no, I've actually measured the module itself.
Okay.
The pin 6 and 7, I believe, um, is the VCC and ground, and I measured that, and there was definitely a short, and I made sure that there wasn't any solder bridges or anything like that.
That is strange because that if it had been due to carbonized contamination on the board, that shouldn't have, well, I don't know what got shorted out exactly, but you wouldn't think that would damage the module. I mean, once the module's off, a short to ground on the module power pins shouldn't damage the module itself, I wouldn't think. Okay, well, pardon me, I am a bit confused as to what actually could have.
I think what happened was moisture got underneath the shield, and because because I was giving it a pretty good clean to make sure to get all 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 of the flux residue off.
Oh, okay, that's right. I forgot about the underneath the shield part. That's plausible.
Yeah.
And I guess that put a heavy enough load on the regulator that it also shorted out to
Yeah.
ground. I mean,
Yeah.
the thing is supposed to thermally shut down in a short circuit case, but I don't know how reliable that is. We hope that doesn't happen.
I might have let it run too long, because it was running for about 2 minutes, and
Yeah.
it was a little over a minute that the output of the transmit output just stopped. And so when I went over to check it, because I was in the other room, when I went over to check it, it was in the case, and it was like really, really, really warm.
Yeah.
So
Can you get a new regulator and put that on the board and bring
yeah,
it up one section at a time here?
yeah, yeah. I think because that was the plan. Was I was going to order the parts, uh, install the regulator, verify both voltages, let it run for a little bit, and make sure that everything's okay. Um, and then if everything's good, then I'll install a new module.
Yeah. Okay.
But yeah, I think that if you're going to um, clean clean the board with solvents that don't evaporate very quickly, because usually with flux cleaner it'll evaporate within a minute or two. But if you use alcohol, and if you use 409, which I was using, they take much longer to evaporate, and if it gets underneath the shield, then it'll take even longer.
Yeah,
So
certainly the rubbing alcohol 70%. If you can get the 90% stuff, it's a little bit better. But there's still water in it, so
yeah, yeah.
um
And so I was so I'm almost positive that that's what happened, and I will take precautions next time to make sure that that doesn't happen, because I I did intend on giving the board a good clean before the module goes on. So once I verified 3.3 volts and 5 volts, everything works good. Um, I'm going to give it a good clean. I'm going to try it again. I'm going to let it dry some more, and then I'm going to solder on the new module. And
okay. And if you have a variable power supply, with current monitoring, um, you know, 'cause if that thing's got it set, what is it, 9-volt input or 12-volt, whatever it is.
yeah, 9.
Yeah, you just crank it up slowly and watch the current, as you bring up the voltage.
Yeah.
And that, if you got a problem, you'll see it before anything starts smoking.
Mm-hmm. Yeah. Yeah, I do. I
Okay.
do.
Well,
So
that sounds plausible and encouraging in a way. I like having problems that we probably understand because, a repeatable problem or anyway, it's good to understand it, and it's probably not a design issue is what I'm trying to say.
yeah, yeah, no, no, I'm pretty much 100% positive that the design itself is solid, and it was just an issue with moisture, and I probably used the wrong solvent, and I didn't have the facilities to properly dry it. I know that there are drying boxes and ovens that you could get professionally that cost hundreds hundreds and thousands of dollars, that have
Some people run them through a dishwasher and let the dishwasher dry it, but
yeah.
I wouldn't want to do that with a module, with that GPS module.
Right, and that's something that I didn't really think about. I kind of assumed that yeah, if everything without gas, everything would be fine. But um, if it's just a regular board, fine. But yeah, with that module, I think it's extra sensitive to moisture. So at least,
Yeah, it's not like in the old days when we used to have, vats of circulating, carcinogenic solvent, whatever it was. It's really good stuff, though. Dip it
yeah,
in there and it dries in a hurry. They have the whole vapor thing and all that. But now we gotta can't use that anymore.
yeah,
Okay,
yeah.
well
So
that's good news. I'm glad you tracked it down.
yeah, yeah, and I mean, this could be a good tip for anyone working with these modules, that if you do end up cleaning a board and cleaning it with solvents that don't readily evaporate, is to um, heed and take caution and make sure that everything is very dry, or else we could get a failure like this.
Yeah.
Um, but yeah, from what I can see, what I could tell, there's no issue with the design. Everything seems to work as intended, and I couldn't find any other issues. So I
Well, let me know when you start bringing this board back up. I want to hear that you've had a successful outcome there.
yeah, yep, yep. I will keep you updated, Paul.
Thank you.
Oh, there we go with the Mars Keyer.
That's a telegraph sounder.
Yep.
And that's a real world thing that came out of a central switching office in northwestern Indiana. Even years after we had things like ohm meters and things, every telephone rack had one of these sounders mounted in it so you could use it for a continuity checker. But it's not very loud. And I don't think, Zoom does a good job of taking transient sounds and things out, so I don't think you'd hear it anyway, but it does work. I got it four D cells running it. Anyway,
I've got a book here. I haven't finished reading it, but it's called The Victorian Internet. Is anybody familiar with
oh,
that?
I've read the book. I've got
Yeah,
the book.
yeah.
Yeah, it's
Yeah, I'm
pretty
familiar with that.
I I have I can't it's actually a copy that a friend made, but George, I think it was George Dodge, but the Dodge was his last name, ran a telegraph school in my hometown back in the late 19th century. And in the 20th century, when wireless came around, it converted to wireless and became Valparaiso Technical Institute, which was very active during the war, training radio operators in both the Army and the negative and the Navy. And the Army used to walk past my house six times a day, marching to the center of town to eat in local restaurants, which were used as mess halls by the Army and the Navy both. And we used to go out and watch the soldiers march by every day. And I was sure they were fighting the war, just blocks down the street where they were living.
So if anyone's not familiar with the book, The Victorian Internet by Tom Standish. I'm looking it up now. Yeah, Standage. Um, it's about the remarkable story of the telegraph and the 19th century's online pioneers, and how they communicated with each other, and just the whole culture and the technology of it. It's I got to get back to it. it's a well-written book, and I was enjoying it until I got distracted.
My favorite
If
aspect of
you,
the Carrington event story is how they were able to run these telegraph lines without batteries.
yeah.
Yeah.
Uh, has anybody read Thunderstruck?
Sounds familiar. I don't
That's
think.
an excellent book on Marconi and early wireless. It's written by it's not a novel, but it reads like a novel. There's a murder story woven in with the story of the wireless, and it's a very good story of how wireless got started and everything. And I would recommend it to anybody who's interested in the history of radio.
Hmm. Yeah, I'm seeing it here, written by Eric Larson. A true story, it says
Oh,
here.
yes.
Yeah, both are supposedly true stories, but he wound up, well, he tends to try and write his historic books with something that involves, where whatever the main storyline is was used, and in this case, the wireless was used to catch the supposed villain.
Yeah.
Although there's a story of the behind the story that brings some real um, significant evidence that proves the guy that was eventually hung for the murder was not guilty, which was demonstrated by genetics many years after he was convicted of the crime of murdering his wife, which isn't part of the book.
Yeah. The DNA part. Yeah.
Yeah.
Well, that's good to know.
So Paul, how are you doing on your PC board designs and uh,
So you're going to start the beatings anyway? Okay.
the meetings are starting?
Yeah. Okay. Uh, I'm removing stuff that we don't need. Trying to just strip it down to the absolute bare minimum that it will end up, being useful for, the basic radio. I need to go through the list of all uh, the firmware, all the pins that either get written to or read from, and make sure that I got everything connected, so that we have, the various modes enabled. Um, I've seen conflicting stuff about the dither mode on the ADC, and I need to go back to the actual source code on the um, for the driver and find out, is that signal actually, is that pin actually being driven or not? Stuff like
Yeah.
that. I want
Uh-huh.
to go back through the driver, basically, output bit by output bit, and make sure I've got everything connected that needs to be connected. A lot of it won't be connected to anything because we don't have the attenuator, we don't have the, VHF chip and the RF switches to switch back and forth between VHF and HF. Um,
Yeah.
but still, some stuff needs to. I need to make sure I'm actually connecting everything that needs to still be connected, and try to connect it the same way it was before to make transition code updates, revisions, simpler. Don't want to have more changes than we absolutely need. So that's what I'm doing. And cleaning up the layout, just moving stuff around as I think I've got a pretty good RF signal flow as far as Ground isolation and, just the flow of the signal path, keeping the RF kind of separated from the digital stuff and, where they meet, having that be as clean as possible. Trying to get the voltage regulators and the high power dissipation stuff, in reasonable places on the board. So it'll be easier to heat sink. Um, I've got
I don't, there's no way to not use a linear regulator. I mean,
I'd be afraid to in this
yeah,
board. I mean, I'm sure that I'm going to have digital hash ingress anyway.
yeah.
And
I'm,
but throwing a switching regulator on there, if I were really, really good at it, I could probably do it. But, we're probably talking about shielded cans and all that sort of stuff, and I want to avoid that
Yeah,
because
it's just asking for trouble.
yeah, I
yeah,
mean, we can deal with the heat. I mean, we just have to know what we're doing.
yeah.
I don't want to add any more noise to the board than I have to. Just an abundance of caution sort of thing.
I understand. That was just just I'm sure you're making reasonable choices there. So
Well, we'll see.
yeah.
Eventually, we'll see. I am working on
Uh,
it again.
uh,
How much power is it?
Oh man, let's see. Let me find I had some notes right here on my schematic. Well, the basic okay, the regulators, yeah, basically the the 3.3 volt regulators or supply. I might be splitting this into like two different regulators. But anyway, 3.3 volt, I got to dissipate a little bit over 1 watt right there. And the 1.2 volt regulator, which drives basically the core of the USB interface chip, it also draws about a watt. And so I'm looking at ways of kind of distributing that power dissipation, maybe having a linear pre-regulator feeding the 1.2 volt regulator so I can, or just power diodes as droppers, but
But
I'd rather use a regulator.
Are you
Just
powering
to,
well,
one regulator
well,
off of another?
um,
yeah.
that, it's questionable. I'd have to, if I do that, I might be powering the 1.2 volt regulator off its own, let's say 3.3 volt regulator, but not use that 3.3 volts for anything else, because otherwise, um, my basic
But
3.3 volts supply, I'm already running
yeah,
over 1 watt on that
because what
dissipation.
what's the source?
The source?
it's
Well,
via
it's
USB
5
5
volt
volts.
USB.
Yeah.
Okay, okay. So, well, I was just getting I was thinking, is this 13.8 or is this going down from 5 volts? But okay.
No, this is coming down
So,
from
so
a 5 volt USB
yeah,
source.
a silicon a Zener diode is a good way to eat up a couple of volts.
Yeah, low voltage Zeners aren't. I, I,
You don't
the
not to use
regulators are
it for a
cheap.
regulator, just use it for a voltage drop.
Yeah, but it's still gonna dissipate the power if you
Oh
drop
Yeah.
a
well,
volt, couple volts.
but it's a different place. You could to dissipate the power. You're trying to spread the power out.
Yeah, but regulators are designed with nice fat heat sink type pads,
Yeah, well,
thermal contact to the board. Uh,
then use
Zeners,
two
I
of
don't
them.
know, maybe Power Zener would have um, but I don't know. A 3
It
volt
seems a big
Zener
regulator and a
is
big
not
heat sink.
is not a very good Zener. I'd rather have a solid regulator. The
You just
regulators are
use
cheap, they're not big, and they have good thermal dissipation characteristics. So
yeah.
I see
Well,
no reason not to use a regulator just to throw away some volts. and
Well,
then spread out the power dissipation that way.
I'm fine with that. I thought you were trying to get away from that. That's all
Oh,
where I was coming from.
well,
I've put regulators in series with regulators.
yeah, no, I mean it's to me it feels a tiny bit kludgy, but it's the best I've been able to come up with so far. Before we spin before we get this board actually launched, I'll share the schematic, I'll share the layout and design notes with everybody here, and and welcome any feedback. We don't have to, there's
How much is he going to draw from 5 volts? You said a watt here, a watt there. That starts to add up.
yeah, it does.
I think the
Is
triple eight draws about 800 mils and 5 volts, I think.
Okay, that's 4 watts.
Yeah, no,
Yeah.
I'm seeing 10, 12, 50, about about 700 milliamps on the 3.3 volt and about 260 milliamps on the 1.2. So that's
Well, that's an amp
seven,
right
eight,
there. If
nine.
you
That's getting
Yeah,
close to a watt right there.
an
well,
amp
that's an
time a
amp right
volt. An
there.
amp
I mean,
time
an
a
amp
volt's a
right there. I
watt.
mean,
You need a volt or so across the regulator.
yeah, yeah.
Yeah, what did he mean by LDO anyway? I mean, I never know what low really meant.
Yeah, there's really low and then there's regular low, and it means it's not like a 7805, the old
Okay. Yeah.
um but it's and a lot of them have they have a PNP pass transistor or maybe a FET in the pass element. But yeah, I don't think there's a definition for how low it has to be before you can call it low. It seems to be pretty squishy.
Well,
Yeah,
I've
I always
used
wonder about, not giving it enough of a drop. And I mean, you want to keep that drop as small as possible to keep the heat down, but it's also got to be a regulate.
Yeah, no, you've got I mean, for the pre-regulator, for some of this, like the 1.2 volt regulator, I don't really care if it's low dropout or not. I'm giving it 5 volts, or maybe I'm giving it 3.3, depending on how I do it.
That should be enough.
Yeah, and
I'm not
I don't really, having a lower drop than necessary doesn't buy me anything because the drop is whatever the difference is between 1.2 volts and its input voltage. So there's your
Yeah.
power right there. It
Well, I
doesn't
can't
matter if
imagine
it's
low dropout doesn't mean less than 1 volt.
what
yeah. So no, I believe me, I'm going to double check the regulator specs before I start running those things in
well,
series. Make sure there's enough margin in all cases.
I I've tended to use the low voltage, the low dropout regulators.
Well, I
Uh,
mean, most of the
I
common ones they call them low dropout. The ones that,
yeah,
uh,
Yeah,
the
people are saying
but there's
317, I
LDO.
think is,
there are no there's regular three there's specific things, or at
I
least
know
there used to be.
people tend to say LDO now just to mean a generic regulator when I know it's not.
some
Um,
are lower than others. You just have
Some
to
are
see
lower
yeah,
than others. Yeah.
yeah. It seemed like there was a Fairchild 28 somebody or something that, but I'm not sure of that number. But I used to use. Well, I think I probably still have some in the drawers downstairs.
I
But
wondered about a hybrid approach where you have a switcher followed by an LDO that lops off any ripple.
well,
Of course, that's not the problem with the
I've
switcher.
I'm less concerned about Ripple because I can get rid of Ripple.
Ripple, yeah. The problem is all the other
It's
paths. Yeah.
it's just the radiating inside that, because no
Yeah.
matter how tight you make the traces,
well, I
there's still going to be loops where
Yeah.
current's flowing.
Right.
uh,
Unless you use complete galvanic isolation, but that's
what
not usually done.
Even then, I mean,
Yeah.
you're going to have a bypass capacitor and the regulator, and you're going to have a series inductor or something in there, or however
Yeah.
whatever the
Well,
topology is.
capacitance between the windings of the transformers.
I
Yeah.
mean, yeah,
Right.
it's going to be, for it to be at all efficient, it's going to be switching pretty fast, and they're going to be anyway. I think
Yeah, we
I
need
don't
a
think
better way
anyone's
of
disagreeing with anyone
we need a
here.
better way to convert voltages without so much noise.
We just need lower power devices.
Well, that too.
Yeah.
Well, sometimes we regulate things that don't need to be regulated.
Right.
Yeah, I don't see any opportunities for unregulated 5 volts on this board. Yeah, I could run an LED off it, but
Well,
on this design, there are other designs where, yeah, don't need to, take whatever voltage you got coming in and you can use it directly. But this, I don't think, is one of those designs.
I always liked putting a regulator on anything that was really critical and put
Yep.
another regulator on what's not critical or not necessarily critical, but it's still nice to have a clean supply.
Yeah. Yeah.
I remember
So
building my
anyway,
first
Rob, that's where I stand. I've got a nice corner of the board, a good size area of it, because I don't have a lot of crap on the board, and I'm using a bigger board than the current 888. So I got plenty of room for the regulators, whatever we end up doing. So I'm not spending a whole lot of time worrying about it just yet. Trying to get the signal flow and control flow worried about and get that, make sure that's all good. And then I'll throw the regulators in their
What's
corner of the board.
what's the environment? Just household or is this
I would assume, you know, 0 to 60, minus 20 to 70, something like that. Not much more than that. But, I'm assuming that, and look, I haven't done the thermal calculations yet because first of all, I'm no good at actual heat sink calculations. What is my, theta J, well, I can pick up the specs to the component case and then, case to air doesn't, or, the whole heatsink connection, what the airflow is, if any. I'm not very good at that, but I'm assuming that we're going to have to go to at least 60 degrees C and maybe 70 degrees C ambient. Um, for the design, that would be and trying to keep my silicon temperature down well under 100 C for chip.
yeah, yeah. I might think the 70 was high, but for I
It's a
like I say, I
goal.
don't know what I really don't know what your I sound you're talking about a 888 and things, so I'm assuming it's something that's going to be in an enclosure in a temperate environment. But
Well, we got, stuff in South, Costa Rica and,
yeah,
Ascension Island,
okay,
on the equator practically. We can't guarantee there's going to be air conditioning. Um,
yeah,
I don't know, but
a
that
box in
that
the sun can get really hot.
yeah, I know. I used to design stuff that had to sit in boxes in the sun, telecom
Yeah,
gear.
me too, me
Yeah.
too.
And usually they ended up putting a fan in it anyway, but we liked it when we didn't need a fan.
Oh yeah, fans.
I
Avoid them.
had I think Rob was talking about the 888 last time and cooling it. And I'm curious, I haven't taken my 888 apart yet. Well, it's not mine. That's why I haven't taken it apart. It's on loan from Nathaniel, but he said I could do anything with it. And I want to clean up take the attenuator out of the input, the antenna input, but that's another story. But um, I was wondering if just turning the 888 so that the fins were vertical and short, stand it up on end, if that would increase the cooling enough to
Well, yeah, no, natural convection, vertical
Yeah,
flow. I mean, it should help. Don't know how
That's
much.
that's really not that's not going to help any. The problem is that that as it comes from the factory, there's really almost no thermal connectivity between the power supplies regulators on the printed circuit board and the external um, case. So it's sitting there floating in an air chamber. The 4 watts of power being dissipated, and so the communication of that heat is communicated almost entirely by the air inside that 888 from the PC board in out to the external case. So that's the problem with the thermal design
maybe
of
we
the
should
shell.
drill some holes.
Yeah, sure. There's
That's been
many ways.
done.
Sure, you could. That's people have done that. I have one here that
Okay,
has a giant hole drilled in
I
it and a
my
fan attached and so on. But actually, it turns out. I mean, it turns out that I mean, it's right here. Let's see if I can show it to you. But I have I have one that Tom Yerish modified. Let's see if I can get the cord over here. You can. Let's see. Where am I? I'm looking at it's this one. You see, you can actually let's see. Hold on. I need to move my cable so I can pull the camera closer to the here. Here's a 888, and there is it has a giant hole in the top of it.
okay,
Okay.
yeah.
And then there was a fan he had mounted on it, but
Oh,
I
okay.
removed. Um but the truth
Was there
is
another hole for air to, flow
well, he
through?
had holes on the end,
Okay,
if you
okay.
said it. So there was, but the reality is that if you put the thermal pads all across the bottom of the printed circuit board, to have increases the thermal conductivity from the PC board to the case dramatically. Yeah, reduces it or increases the conductivity. And with that, there's the CPU the chips run around 50 C instead of 70 or 80 C from is what I could tell they were running at.
It's,
You're talking about
it's,
case temperature on the
I'm
chip?
talking about the chip. I'm talking about the chip. The chip. What I can measure with my little heat gun thing.
Okay, so not
The
okay,
chip
so that's
tempers are
that's
highest.
not silicon temperature. That's
No.
that's the case. So
yeah,
you
it's,
Yeah.
got to work that backwards,
Yeah. Yes.
theta J
Yeah.
case
But
to see what the
clearly, yeah. Yeah. But clearly running the chips, the cases at 70 or 80 C are really pushing the any silicon. I mean, that's not a good place to be.
yeah.
But the thermal pad material, which is in the Triple H you have, Bob, um,
You're
that
saying
thermal
it's in
pad.
there? You're saying it's
Yes,
in there?
oh
Okay,
yes,
okay,
yeah.
okay, okay.
So it's in there, and that really solves, I think, 90% of the heat problems of that design. I mean, it's still not good, but it's okay. And
Okay,
I don't think we've seen a permanent failure. I may be wrong, but I don't recall a permanent failure of any of the modified triple eights. We are having problems with the triple eights disappearing from the USB bus and only recovering if you physically
yeah, yeah. That
replug them.
that happened on mine, if you remember.
Yes,
You
that's
pointed
yeah,
it out to me.
yeah. And we're experimenting with some code that turns on a watchdog microcontroller inside the USB chip, so that if that watchdog sees no USB transfers happening for X seconds, we're doing 20 seconds, it reboots the USB chip.
Okay, okay,
So so this is an intermittent problem, which means it's very difficult to reproduce. But we do we had this happening regularly at Glenn and 6GN on one of his triple eights. we started trying to swap things between a good system and a bad system, move the 888 from one to the other, swap the two of them. The problem didn't suddenly both of them were doing it for a while. Then we swapped them back, and neither of them now will do it at all. So, I mean, it was
In
just,
there.
yeah, I'm sure we've all been to these. So, so we have another site in at Baldock, which is the Ofcom receive monitoring station in their FCC in the UK has a monitoring site outside of Cambridge called Baldock, and we have a system installed there, uh, and it is exhibiting that problem. So I'm experimenting by swapping in the Watchdog enabled USB firmware to see if that, it doesn't fix the problem, but it means that you don't have to send somebody out to a remote site to have them replug the 888s. And sometimes one replug isn't enough. You have to do it multiple times. So then the person who's out there who knows nothing about this equipment, power cycles, it turns it back on and says, I've done it. Well, you go and look at it, an hour later. I mean, they're 8 hours ahead of us. So, and by the time I get to it, of course, they're home in bed. Oh, that didn't work. You got to go out again. Uh, so, I mean, this is a maddening problem that hopefully one of the benefits of Paul's work would be that if this occurs, at least we'd have a way to trace it down and debug it and fix it. So, in the meantime,
Yeah,
we're doing what we can do in the firmware. So,
yeah, I mean, if depends on what's the cause of the problem. I mean, I'm duplicating as much as I can as far as connectivity and function,
yeah.
so if it's that kind of design problem, then what I'm doing won't change it. But if it's a thermal or a manufacturing issue, maybe what I'm doing will be an improvement or a change or something. Hey, Rob, different subject about Ellesmere. Weren't we talking about sending them a Raspberry Pi for remote access on the Whisper Sond?
Let's see.
Was that Ellesmere? I thought it
No,
was.
no, it was for Dave Schwartz at the
Oh,
WWV,
WWV.
and yeah, it's backed up on my to-do list. I'm sorry.
I've found a couple old Raspberry Pis here.
Oh, that would
Let me know if that's something I can.
it would be great if you could just set them up.
Well,
Uh,
that's the thing. Setting them up, I'm gonna need someone to hold my
it's
hand through the whole process again.
it's so easy. It's really easy. I can.
Good, but
Okay.
it doesn't mean I know how to do it.
Yeah,
So,
no, I can walk you through it, and you can do it in 10 minutes. You can install the new operating system on them. So,
okay, let's, tomorrow or the next day or something,
okay.
when let's let's get together and
Okay.
do that.
Okay. Yeah, you can look for me or look around for me. I've got multiple projects going on in
Yeah, I
parallel.
mean or it could be
Uh,
next week for all, it doesn't
yeah.
matter to me.
Yeah.
Um, but I at least I got the Raspberry Pi and I'm happy to donate it to
Uh-huh.
the cause.
Well, that's helpful. Because I have two Pi 4s here, which are overkill for that application, and I wanted to use them for that KFS.
Let me see what. Oh, let me hang on. This is an old one. I'll turn it right side up. Raspberry Pi 2. Is that
Well,
too
I,
old?
prob- if the operating system will install, it'll be fine.
Okay.
Let's see if let me see. There's the latest Raspbian can be installed on a Raspberry 2. Let me ask Claude.
Okay. And yeah, tell me which version of the Raspbian. So are we still doing the not non UI the window, not the windowed version?
Oh,
Or
I thought
can it, if
that.
it if I recall, if we can make it work with the window version of Raspbian installed, then whatever gets
Oh,
installed with the windowed version, that took care of the USB serial port location problem.
yeah, it had to be the Windows version, but you can install Bullseye on it. You can't install the latest, but you can install Bullseye, which is I think the 32-bit. That's
Good
you can,
enough?
yeah. Uh, okay, so so if you can you just load a program called Raspberry Pi Recorder. They have a
I mean, I've done I've burned the little chips and done the
yeah.
I
Well,
can do that part.
the
This
Raspberry Pi,
little
there's you put that you run the Raspberry Pi imager program you
yeah, no,
download
I've
from
done
their
that
site.
plenty of times.
Yeah, and you can in there you just need to select the appropriate OS for that Pi 2, which would be a Bullseye 32-bit Bullseye,
Okay.
and put it on there, and then after that, um, I mean, you could install Whisper Daemon. I'll give you a remote access channel, and then I'll take care of the rest. So
Okay. Well, let's not do that tonight, but
yeah.
in a few days when you've got the time, I'm generally